So I would like to welcome our speakers, Satheesh and Preethi. Satheesh is a performance and accessibility engineer. He is working with WNS Vuram. He was an ex-Cognizantite. I think the previous session was also from Cognizant. Preethi is also a performance test engineer. It will be really nice to know and have an interactive talk about revolutionizing performance test analysis. I think they're going to use JMeter and also throw some light on MLP and GNN. A very warm welcome to you both.
Thanks, Deep. Thanks, Deep.
Yeah. And audience, if you have any questions, feel free to put it on chat. We'll take it up with the speakers. Over to you guys.
Yeah, thanks, Deep. I will share my screen now. Share. Okay.
Yeah, we can see it.
Okay, just a moment. Yeah, okay. So, myself, Satheesh, and I have my colleague Preethi with me as well. So, we have been part of Cognizant. I just moved out of Cognizant, so I'll stay with the Cognizant itself. So, I've been part of Cognizant for the past 4 years. So, where I have been into performance and accessibility testing. And my colleague Preethi, she is also part of the team. So, she's also into performance and accessibility. And first of all, I'll just give a brief introduction about performance testing. So maybe that will be much more helpful here for the audience as well. So performance testing comes under the what to say the bucket of non-functional testing, where it has multiple categories such as performance, accessibility, usability, compatibility, security, and everything comes under this. So what these testings mostly favor is like it mostly takes care about the end user perspective, how the end user would see the site or the website or the application or the mobile app. Everything comes under that. And also I want to throw a small a highlight on the accessibility testing as well. So we need to create more awareness about the accessibility testing to the greater audience and the people, general public here, because what concerned me is like the features about accessibility are much more used in other countries like US, UK, and everything. But I did see a post in Instagram that a small person using the accessibility feature in an iPhone is being celebrated like a huge thing. But what I would see is like it's very much evolved technology in the other countries that needs to be or created awareness here in this country. So that will be much more appreciated if you go and explore that a bit. So when it comes to performance, right? So performance testing, I'll just give an example about the performance testing. So we will be aware about the what to say Amazon days or the festive season sales and everything. So what if the site gets down during the peak hours of the festive seasons, and that would create a great loss to the organization or everything. So this is where the performance testing helps us a lot. So what I would say is like the performance testing plays a key role where the what to say the organization would find how much users the application would be able to handle during the peak session or the particular period of time, and that would help them to like what to say change the server's capability and everything. So the performance testing also plays a key role in the testing phase. Actually mostly the performance testing comes at the end of each what to say each at the end of the development phase, testing phase. So this would be the last testing that we do before the application goes to live. So in this, right, we do have multiple applications. Like we have JMeter, we have Neoload, and latest we see a tool called K6 that is picking up a lot. But what's majorly used in the market is like JMeter is being used majorly in the market. So because JMeter is an open source tool, and as it's open source, there is no cost. So we just use the tool that is being present. And other things are what's a paid versions and licensed versions. So we just went with the JMeter thing for the paper presentation. So but it's better we just know about the other tools as well. So uh, And I would say like we wouldn't say like this is being involved with Gen AI and everything. So, but what we saw from the current trends is like the scripts are being developed by us, and that's being pushed into CI/CD pipeline, and the tests are run, and we get the results from them. So these things are automated, but we didn't see the automated or the analysis model for the test results which we derive from the JMeter. So what we planned is like, why don't we come up with a solution to what to say to get the result analysis of the test. So what currently the process which we follow is like, we have to go through a lot of previous test results and keep them under our uh, like in the notes or something like that. We have to know all the things. So or like what are the like at which time the server peaked and which time the response times are higher and which time the server gone down. So everything these details, and it does multiple numerical details to be precise. So those all things, right? We like we being humans, we can't be able to keep everything in our brain. So what we thought is like, why don't we create a model? So we do already have an automated process till result generation, but we don't have the process for result analysis. If we used Gen AI or the Copilot and everything, we had a session like the privacy of the customers would be leaked to the world. So that is one thing that was concerning to everyone. So what I thought is like, why don't we have a closed model that would give us the result analysis rather than an open AI model, rather like Copilot or Gemini, something like that. And we can also create a specific Copilot model inside our organization, but that would be a much cost when it comes to a certain application, right? So that will be a much more costlier when compared with application cost. So a separate model that's being indigenously developed, right? So that would be much more helpful. So I'm going to walk you through like the model which we tried to come up with. So the model which we had thought of is like using the MLP and GNN. So the MLP is nothing but multi-layer perceptron. So it's nothing but a neural network. So many of you know about neural network. So it's like our brain. So it has multiple nodes, neurons, and everything, which has the data which we pass. So and also the graphical neural network. So this is indigenously that's been there for graphical data. So combining these two, right, we thought of doing a model. So this model is being again split into two models. So what we do is like, one we split into what to say numerical data analysis model and graphical analysis data model. Because what data which we get from JMeter is like, we get both numerical data and graphical data as well. So a single model, right, with the both two different features, right, won't be a proper way to do it. So we thought like, two models for the numerical data and the graphical data, and we combine it at the later part. So the numerical model uses the multi-layer perceptron. So the why we use multiple layer perceptron is like, that's being used generally like specifically for numerical data, where it has an input layer and an output layer. So this is one of the basic things of the multi-layer perceptron. And it also has an hidden layer. So the hidden layers does the magic. So it has multiple neurons and data and weights and biases, everything. So where the result is being what to say analyzed or being properly read. So that's being done where we pass our data to them. So we like on coming up to a what to say a model, AI model, right? At the first part itself, we won't be getting up the proper results which we are thinking of. So we have to go for an what to say what to say to fine tune the model. So for fine tuning the model, right, we suggest a principle called back propagation. So back propagation is, to be precise, right, back propagation with errors. So what we do in back propagation is like, we compare the output with the desired output. So what to say, the output is like ABCD, and we get the output like something mixed up like CDAB, something like that. So we compare the output, and the comparison, the back propagation algorithm, it take care of the comparison and the calculation of weights and the uh, pieces, biases and everything. So it adjusts the weights and the biases of the each test. And after fine tuning, right, we may be getting the what to say, the precise results required. So the precise results that is being done, like that's being majorly seen here is like we get the minimum response time, average response time, and the 90th percentile. And the main feature, key feature which we are seeing here is the error rate. So these 4 to 5 features, right, will be analyzed, and the what to say, and also the algorithm adjusts everything, and what to say it predicts the results from the previous results, like it compares the previous results, and it says like which transaction or which functionality is being down during this particular time. So these analysis, right, we get it from this numerical data analysis model. So moving on to the graphical data, right? So the graphical data majorly consists of average response time. So this is one of the key feature that we see, and also the hits per second. So how many requests are being passed to the request, like to the servers or the DB servers or everything. So this is another one thing, and also the number of users that's using the application during the particular period of the test. So these 4 to 5 features, right, plays a key role in analyzing the test results. So so the graphical neural networks, right, it uses the graphical embedding. So graphical embedding has multiple nodes and edges, as you see, like when we pass on a data, so that's being pushed into nodes and edges where the data is being nodes or edges is that is nothing but a spike in a graph. So the spike in a graph is being stored. For example, the test duration is for 1 hour, and we see a spike at the 30th minute of the test. So it stores the data like at the 30th minute of the test, we see a spike in the response time. So that data is being captured, and this is one of the key features that needs to be sent to the stakeholders. So where they would analyze why the 30th minute of the test it got spiked, or the response time or the CPU memory got spiked. So these are the features, right? So that's being focused during the test. So these in graph structures are being analyzed, and after that, right, so after that, and to, like as I already said, right, we won't be getting an optimized model at the straightforward case. So to optimize the graphical model, right, we go into two strategy training. So the first strategy which we are following, which we followed, is like progressive supervised learning. So it is nothing but we give new data to the model, which will be trained again, and after that we see the accuracy of the test. So this is one of the optimizing method that's being commonly used. And to another way of optimizing is the policy gradient method. So it's also gets the data, and it analyzes all the data, and it stores the particular important values, and it passes to the model, and it gets trained. So we see multiple optimizing strategies with the graphical data. Like when we compare to numerical data, right, the graphical data that's being passed is very complex when compared to the numerical data. So what suggestion for this we would say is like we need to get an bigger data sets. Data set is nothing but a proper report that's being generated with for example, there is a graph, and we give the complete analysis, the human analysis of the graph to the model. So this is the data set which we will be passing on to the model, and it gets trained. And after the train, we will get an accuracy. So basically, the accuracy needs to be higher than 80% sometimes, and sometimes the stakeholder would come up with an accuracy of 90%. So the training of the model, right, gives us the accuracy that needs to be achieved. So that is one thing we have to be very cautious of. So the accuracy basically like majorly depends upon the optimization of the model. So the optimization depends majorly on the test data which we give. So the test data needs to be prepared by ourselves. So it needs a human, like lot of human intervention. But once we complete this model, right, the human intervention would be the we would be reduced for sure. So the conclusion what we say is like these two models separately gives us the numerical data analysis and the graphical data analysis. So we combine this model using TensorFlow or something like it. So we are not sure of what the integration part. So but these two results, right, would help us a lot to analyze the results. I mean the results from the model, right? It would help us lot because the result analysis, right? It takes a lot of human efforts because it needs to gather every data from all the persons, and we have to contact every person that's being there, and we need to get the data from there, and we have to analyze each and every data. That would take one a day or two. It depends upon the errors which we get. So these things, right, will reduce the human efforts, but by a lot. But what I would say is like as of now this being done manually, but the analysis model, right, it would create a revolution in the future. But everything's under development phase. But what I would say is like as the AI is picking up, so this would be much more easier to do it in the coming days. But it's all depends upon the what we do, because the optimization and the test data required, right? We need millions of test data. It's like millions of record we need. So that is taking much time for us to prepare rather than the model. So the model preparation is much easier than the test data preparation. So that's the only thing. So once this is done, right, this would create a revolution in the result analysis phase. So and this is not confined to just the JMeter. So we can pass it either as an CSV file or everything like that. So we just took an example as JMeter, but it's generally we would say like it's a normal result analysis model where we can pass it a HTML report or a CSV file or any type of results, right? So that would come up with the perfect results of the test. So this is what we have been doing for this paper. So for this, right, so this is the just a pictorial representation. So we just first we get the HTML report of the CSV file. We pass it to the multi-layer perceptron, that is a numerical data analysis model, and that gives the results, and the graphical data is passed to the GNN. And for optimization, right, we push it on to the policy gradient method. So once that's done, so that is the um, what to say, the result analysis model in nutshell. And integrating both the models would give us the complete result analysis model. So where the results can be either put onto a dashboard, or it can be exported to Excel, or either it can be pushed directly to the stakeholders. So this can be integrated with the CI/CD pipelines. But the result analysis model, there's this being in the main picture, right? So this is the one thing that needs to be integrated with the CI/CD pipeline. So this needs to be worked upon. So once this is done, right, this would create a revolution for sure in the performance testing backgrounds. So that is from my end. Is there any
Is
questions from your end?
Preeti going to take over or you want to see if there's any questions?
No, like if there is any questions, right, I would be loving to
Okay.
take.
Uh, as of now, we don't have any questions,
Sure, sure.
Satish. Does Preeti have another part to present?
No, yeah, it's
Okay.
yeah. Thanks, Deepthi.
Thank you, Satish.
Yeah.